All right, this video is going to show you how to determine if a function is even, odd, or neither algebraically. So first I'm going to show you the way that you're supposed to do it, and then I'm going to show you the way that I do it. If you get in trouble with your teacher for doing it the way that I do it, well, I'm sorry in advance. Here we go. Technically, in order for a function to be even, f of negative x has to equal f of x. And I'll show you what I mean. I know that doesn't make a lot of sense right now. I'll show you what I mean by that. Just hold your horses. In order for a function to be odd, f of negative x has to equal negative f of x. So if you're already confused, that's okay. Hang in there. I'll show you some examples and you'll get the hang of it. So let me write over here. Even, odd. All right, so take, for example, a function like f of x equals x squared. Well, if it only has one exponent and it's even, well, then it's probably going to be an even function, but you still need to check. So we're going to use this right here and check this. So basically what this red circle means is you need to come over to your equation and plug in negative x. So now instead of writing x, you're going to write parentheses negative x, like that. And then you kind of want to work it out algebraically and see what happens. If you have negative x squared, that's like saying negative x times negative x. And a negative times a negative makes a positive. So f of negative x equals, when I multiply these together, I get back to original x squared. Notice that my original matches when I plugged in negative x as well. So that means this would be an even function. Let's look at another example of an even function. Imagine something like f of x equals x to the fourth minus 3x squared. Okay, there are two exponents and they're both even, so you could probably use common sense and say that this is even, but you're still going to have to prove it algebraically. So here's how you would do that. You would plug in negative x for both of these x's, both of them. So it would look something like this. Negative x to the fourth minus 3 negative x squared. And then you kind of have to do some algebra to work this out. So negative x to the fourth is like me saying negative x 4 times. And then the same thing with the negative x squared part. That would be like me saying negative x twice. So when you multiply this out, this negative x 4 times is just going to become positive x to the fourth again. And then this negative x times negative x, this squared part, that's just going to become x squared again. So when it's all said and done, I plugged in negative x and I got my original equation. So that means it's even. All right, now odd functions are a little weirder. Basically, for an odd function to work, let me just show you an example. Imagine f of x equals, let's just do a linear, like 2x. When you plug in negative x, so plug it in the same way as before, and you do your algebra and work it out and get your final equation. All right, it has to be negative 1 times your original. So essentially what that means is you have to be able to factor out a negative 1. So divide everything by negative 1. Then you get back to your original. That means it's an odd function. So I'll show you a couple more examples so you can kind of get the hang of it. Imagine something like f of x equals x cubed minus 4x. Okay, well, kind of using the same trick as before, looking at the exponents, this one is odd, and this one doesn't have an exponent, but there's one there. It's a 1, so that's an odd as well. You're still going to have to prove that this is an odd function, though. So plug in your negative x. All right. This negative x cubed part is like me saying negative x 3 times. And when you multiply that out, you're going to get negative x cubed. And then this other part over here, negative 4 times negative x, becomes a plus 4x. So when I plugged in negative x, this is what I got. And remember, I said you have to be able to factor out a negative 1 and then have your original. So divide everything by negative 1, and you get x cubed minus 4x. And if you look at this, it's the same as what I started with. So that would mean it's an odd function. The same as what I started with when I factored out a negative 1 is what I meant. Okay, now imagine this same equation, but at the end it has like a plus 1. Even, odd, or neither. Well, plug in your negative x again. Do your algebra and work it out. You'll get negative x cubed plus 4x plus 1. Factor out your negative 1. Okay, now look at this part here in the parentheses. It does not match my original. The end part, the minus 1, does not match this plus 1 that I needed. So this would be an example of a neither. Okay, now the way that I've always done these that might get you in trouble with your teacher is, let's imagine that same example. We'll just start with this one. Okay. You can tell if it's even, odd, or neither by plugging in a number. So what I mean by that, if I plugged in number 1, it would look like this. 1 cubed minus 4 times 1, which would be negative 3. Now, you would plug in a negative 1 as well. And do your algebra, you would get negative 1 plus 4, which is positive 3. Notice that they are negative 1 times each other. That would mean it's an odd function. Here's an example of me doing that with an even function. So something like this. So I'm going to plug in 1, and then I'm going to plug in negative 1 again and see what happens. So f of 1 would look like this. And if you do your algebra there, you get negative 2. And then plug in negative 1. Do your algebra there, and you would get negative 2. And when they match, that's an even function. So an example of what that'll look like when it's neither would look like this. All right, I'm going to plug in 1 first. If you plug in 1 and do your algebra there, you would get -2. Now I'm going to plug in -1. Do my algebra there. And I would get 4. When they don't match at all, and they're not -1 times each other, that's what a neither looks like.